Okay. Assalamualaikum and good morning to Sir Fahmi and our fellow friends. Today I will be explaining about solid biomass fuel preparation. This process is used to prepare biomass materials such as wood chips or agricultural waste to be used as fuel for producing energy. The whole system is divided into four main parts. So for the first part is receiving system, and the second part is a processing system, and the third part is buffer storage system, and the last one is a fuel metering system. So first, in the receiving system, biomass is brought in by trucks. The truck tipper unloads the biomass into a large container called a hopper. From there, the conveyor system moves the material continuously to the next stage, and radial stacker then arrange the biomass into large and uniform parts for storage. This helps save space and ensure that there is always enough materials ready for processing. Next, we have the processing system. This stage prepares the biomass before it enters the energy conversion process. The biomass goes through separation to remove metals and other unwanted materials, and bindings or shredding to reduce its size. This makes the fuel more uniform and easier to burn efficiently. Several machines are used here, such as feeders, conveyors, metal separators, dryers, spinners, and grinders. Finally, an automatic feeding system ensures the correct amount of biomass is sent to the boiler, where it is burned to produce energy. I will pass the next stage explanation to Edward Saka.
Hi, I will continue the next step is buffer storage. Think of this storage unit like a giant thermos or a terminal battery for our system. The boiler needs to warm up slowly. While it's warming up, it might not be working perfectly, so the buffer takes hold all the extra heat and hot water the system needs to a full 24 hours supply. Its job is simple. It acts like a stabilizer. If the boiler needs a sudden increase of heat, the buffer tank immediately supplies that heat to keep the whole process steady and smooth. It prevents stop and start. Next, we have fuel metering. It uses a device called an auger, which is like a giant screw to feed the fuel from the storage soil into a small staging area called the sugar bin. The boiler controller constantly watch how much heat is needed and adjust the meter to deliver the biomass at the perfect speed. Too much fuel is waste. Too little means no power. Metering makes sure it's balanced. The heat boils water in a spread container which turns it into steam. This steam flows through a power generator turbine to spin it and produce DC voltage to be used in household.
Biogas. What is biogas? Biogas is formed when microorganisms, especially bacteria, degrade organic material in the absence of oxygen. Biogas consists methane or carbon dioxide and small amount of other gases. Biogas is about lighter than air and has an ignition temperature between 650 and 750 Celsius. It is a odorless and colorless gas that burns with a clear blue flame. And that's all. Thank you.
Moving on to the biogas fuel preparation phase. The slide explains two different ways of collecting biogas, that being through biogas plants as well as landfill gas wells. The biogas plant is a fully controlled and closed system where organic feedstock such as food waste or animal remains go through pre-treatment, where it is then ground or softened for easier microdigestion. It is then fed into an oxygen-free tank called a biodigester, where the microbes break it down to produce the biogas. In this system, the gas rises to the top of the tank and is collected through sealed gas pipes and storage domes. Landfill gas wells, on the other hand, is an open system which deals with decomposing waste already buried in the ground. Organic waste breaks down naturally under the landfill surface, and gases build up under those surfaces in waste layers. To collect the gas collection wells are drilled deep into the landfills to access these gas deposits. The wells are connected by a network of piping that channels the gas into a central collection point, where it is then processed. To explain how it is processed, I'd like to pass it to my friend Hafizul.
Okay, so the next is once raw biogas is produced, it moves into the biogas utilization section where it's refined for use. The first major step here is the Schrumber H2 gas. Raw biogas contains hydrogen sulfide. The Schrumber removes the impurities, making the biogas safer and more efficient for subsequent use. Sometimes excess biogas or biogas that doesn't meet quality standard for energy generation needs to be safely disposed of. This is where the flare comes in, combusting the gas under controlled condition. From the scrubber, the biogas then passes through a dehumidifier. Moisture removal is vital as water vapor can reduce the energy content of the gas and cause corrosion in engine or burner. With H2S removed and moisture reduced, the purified biogas is now ready for the combustion system to generate energy. One common application is feeding the biogas to a burner or boiler. Here it's combusted to produce heat, which can then be used for various industrial processes or to generate steam for electricity. Alternatively, the clean biogas can power a gas engine by convert the chemical energy into mechanical energy, which is generate electricity. Throughout this entire process, from pre-treatment to energy generation, an essential element ties everything together. This system continuously monitors parameters like temperature, pressure, gas composition, and flow rate. It's providing real-time data and automated control. So that's all from me. Thank you.
For the process of building a gas collection system is the first step, the identify gas source. So, in the biogas plant, the gas is produced inside a sealed digester that breaks down organic waste. In a landfill, gas formed naturally from decomposing waste and is collected through wells placed across the site. And the second step is determine gas flow rate. So next, we estimate how much gas will be produced per hour or per day. This value is measured in cubic meters per hour. It can be estimated using data such as the amount of feedstock in a digester of the waste volume in a landfill. So for the third step is a select gas velocity. To design the pipelines, we must decide how fast they should move through them. The gas velocity is usually kept between 3 and 7 meters per second. If it's too slow, moisture may settle in the pipes. If it's too fast, it causes pressure loss. And the fourth step is calculate pipe diameter. Once we know the flow rate and gas velocity, we calculate the pipe size using two formulas. So this is the two formulas that we given. So
for the fifth step, design pipe layout. Now the layout of the pipes is planned. The total distance between the gas source and the storage or treatment system is measured. The pipelines are designed with the 1% downward slope, so the condensed water drains toward condensate trap. This prevents blockage and keep the gas path clear. For the sixth step is add safety and control component. Safety equipment is added to control gas pressure and prevent accidents. This includes pressure relief valves to release extra pressure, flame arrestor to block fire from moving through the pipes, and flow meter to measure gas production. In landfills, blowers or vacuum pump are also installed to pull gas from. For the seventh step is include gas treatment. Before gas can be used, it needs to be cleaned. Treatment units remove hydrogen sulfate, carbon dioxide, and moisture to protect engines and ensure safe combustion. Common treatment equipment includes scrubber and filter. Lastly, direct gas to storage or utilization. After cleaning, the gas is direct either to storage tank or gas bags for later use, or directly to power generator or flares. The system must maintain steady pressure and flow to support continuous engine production. So that's all for our tip. Thank you.